This experiment is about expandable search networks. It's about how ants can adjust the shape of their paths to search a space in the best possible way, adjusting their searching to the number of ants and the size of the space.
All right, we are getting ready to set up the Ants in Space experiment, part of the CGBA Science Insert program conducted by BioSur Space Technologies. And there's a curriculum associated with this as well that came out of the Baylor College of Medicine Center for Education Outreach. And so what we're using are common pavement ants. So the common pavement ant is found all over the United States, all over, probably all over the world, and they're commonly on sidewalks, or you might see them around foundations of buildings. And these ants typically are in colonies with one queen and up to 10,000 worker ants. And those worker ants, a lot of what they do is forage. And their behavior as they do that foraging is one of the things we're going to be looking at in this experiment. Typically, the area that an individual ant will forage in is somewhat dictated by how many ants are in that area, how big the area is. And so if there's more ants in the area, and as they meet each other, they're going to continuously turn, and their area of searching is going to be a little bit smaller. But if there's less ants or a larger area, they're going to be able to walk in a straighter line. And so a couple of the questions we're going to look at today are, in the larger areas, do the ants, do they go in a straighter line? And also, how is that impacted by microgravity? And one of the neat things about this experiment is that it's going to have an educational outreach. So classrooms, kids down on Earth can set up their own control experiments that will look very similar to this, and they can see how the behaviors of the ants might change in microgravity versus their ants that they might have down on the Earth. And so that's kind of a neat aspect of this experiment, is that the kids can participate in it. And in fact, I think if teachers are interested, they can go to bioedonline.org and probably find out some more information on that. So let's talk about the test setup. What you see at this point is there's 4 habitats here, and each of the habitats has a nesting area, and you can see the nesting area up here, and that's where the ants are at this point in time, how they came up in the rocket. And then what will happen is we have an area, foraging area A and a foraging area B. And so the first phase of the experiments will open up the forage. There's a wall here that's keeping the ants in the nesting area. We'll open that up, and they'll be allowed to come out and forage in this smaller area. And so we would expect, based on the behavior, that they would work and have more turns associated in their foraging than they will when we open up the second wall and give them a bigger area. And in this case, we would expect to see them walking in more straight lines. And so that's kind of the basics of the test setup. What we'll do is we're going to start with just the 2 upper habitats, and then we'll at a later time move to the lower habitats. So right now you can see the ants in their nesting area. There is food available through that little rope that you can see. There's a liquid that they can have access to, and I guess they need to have a lot of fluids because they are so small. And in fact, I think if teachers are interested, they can go to bioedonline.org and probably find out some more information on that.